Hello, Ravens. Welcome to Foundations of Physical Science. Today we are talking about Measurement, Chapter 1, Section 1. Okay, Chapter 1 Measurement has to do with measurements, time, distance, converting measurements, and working with measurements. This PowerPoint will focus on measurements. Learning goals for Sections 1.1 are define measurement, which is your learning goal 1.1a. Comparing the English and SI measurements, which is your learning goal 1.1b. And becoming familiar with metric prefixes, which is learning goal 1.1c. We can skip this, this is something we can skip. Let's move on. Actual measurements. Okay, so definitions. A measurement is the determination of the amount of something. So it's always a how much kind of a thing. Measurements are always referring to how much. How much has to tell you, there needs to be two important pieces of information when talking about how much of something. You have a number value, say 10, but you also have to have a unit value, because if all I say is 10 what? For example, if I said walk 10, well, do you want me to walk for 10 days? Do you want me to walk for 10 minutes? Maybe you want me to walk 10 feet, maybe 10 miles. Okay, so without the unit, the number itself has no meaning. And so a measurement is determining an amount of something. So you've got to have the number value, and then the unit value identifies what that number refers to. Units are consistent across the entire world. We try to keep units the same. So in other words, if you were to order, say, 5 grams of a substance and you ordered it from Europe, you want to get 5 grams of that substance. So 5 grams in Europe should mean the same as it means here. And that's where we get systems of measurement, which are agreed upon standards. Okay, nice little graphic here showing you, all right, excuse me, showing you some measurements. So 2 meters, 2 is the quantity, meters is the unit, okay. Average person is about between 1.5 meters to 2 meters tall. Whereas a large dog, or even a medium-sized dog, you're looking at more like not quite a total meter. Okay. So we have 2 common systems in the world that we use for measurement. We have what we refer to as the English system, or the standard system, and it's pretty much used every day here in the United States. That's what you've grown up with and what you're used to, if you grew up in the United States. Units that go in the English system, you have miles, yards, feet, and inches. Those are all units of distance. Pounds are units of weight. Then you move to pints, quarts, gallons, cups, and teaspoons, and those are all units of volume. Those come, cups and teaspoons when we're cooking. Okay, we purchase our gas in gallons. Okay. The metric system, okay, which was revised and simplified back in the 1960s, but it's been around for quite a while, was adopted as an international system of units because we need to have consistency. And if you want to look up an interesting article, read about the Mars orbiter, and there's a very expensive error that took place due to the differences. Engineers tend to use the English system of measurement, where scientists tend to use the metric system. Okay, that's something we must be aware of when scientists and engineers work together to build a satellite to orbit around planets. Okay. International system of measurements, we refer to it as the SI or the metric system, okay? This idea of SI is from Le Système International des Unités. I can't speak French, obviously. Okay, anyway, we call it SI. And the French are the ones that house all the standards for all the measurements. Okay? SI units are on a base 10 or a decimal system. It's very easy to think of metric systems in terms of money because it works the same. A dollar is your base unit. Okay? Just like a meter or a liter or a gram or a degree Celsius or a watt or a byte if you want to talk about computer information. Okay, so in the same way that 1 cent is 1/100th of a dollar, a centimeter or a centigram or a centiliter or a centibyte or a centa anything is 1/100th of whatever that base unit is. And you can do the same with milli and with kilo and hecto and that kind of stuff. Some of you may remember something in the form of, I always said it as King Henry died by drinking chocolate milk. Okay, but some King Henry something, kilo, hecto, deca, base, deci, centi, milli. Should sound familiar to you from your middle school days. Okay, so in the metric system, we have millimeters and centimeters. Every centimeter is made up of 10 millimeters. 100 centimeters make up a meter, in the same way that 100 pennies make up a dollar. Okay? There are 1,000 meters in a kilometer. There are 1,000 grams in a kilogram. There are 1,000 liters in a kiloliter. Okay, so kilo always refers to 1,000. All right, here we're going to get a closer look at the meter stick itself. Okay, a meter stick is 1 meter long, and it's divided into millimeters and centimeters. You may often refer to it in class as a yardstick. However, if you look closely on the English side of the meter stick, you will see that a 1 meter is slightly larger than a yard. Each centimeter is divided into 10 smaller units called the millimeters. Okay, so looking at how we measure this. Okay, you're all pretty good at this. Everybody would agree that this bolt is at least 4 centimeters. And I'm going to pull up the pen here. Okay. All right, and so when we measure length or the distance of something, you're measuring the space that it takes up, how long it is. Okay, and so I am going to draw the best I can straight line coming down through this. Okay, so reading this ruler, it is in centimeters. Every one of these big lines is centimeters. Okay, so I would have to say that this bolt is 4 centimeters long, but it's more than 4 centimeters long. It's 4.5, there's 6, and I'm going to say, going down my line, I know it's not exactly straight, but I would have to say it's not just 4.6. Okay, there's my decimal, because my unit's going to be in centimeters. Okay, they're 4.6, maybe 6 centimeters. Okay, or I could be off completely with the way my line is being drawn, and it could be really, really close to just the 0.6. Okay, So when we talk measurements, and you'll learn this a little later in this chapter, this digit right here, the last one I write down, is what we refer to as the uncertain digit. But however you look at it, we know for certain that this bolt is 4.6 centimeters long. Okay? Now, your sophisticated scientists are going to always measure one digit beyond. So we're always going to try to make an estimate in the space, how far it falls into the space in between. And that space in between is where the 6 came from, the uncertain digit. Okay, so let's look at another one here. Okay, here is the pencil, and there we go, erase the pen. Alright, so now we can do this here. Now this pencil is not divided up. I mean, it's not lined up with the 0 mark over here. So I'm going to have to do this very carefully. First, I'm going to get my pen, and I'm going to do my best. Okay, not very straight, but I think I'm pretty straight far down. Hard to draw on a computer, at least for me. Okay, that one came out pretty good. Okay, so now I have to figure out, it's starting here at 1.5. Okay, so 1.5, I could do this in one of two ways. I could start here, and I could go, well, that's 1 centimeter, right? The halfway to halfway. There's 2 centimeters. That's 3, 4, 5, 6, 7. Okay, and then I'm going to get it at 7, but it's not quite 8. We'll get 7 point. And how many milliliter lines did it take? 1, 2, 3, 4, 5, 6, 7, 8. Okay. And if we look, that looks like it's right there, barely on the line. For that one, I'm going to estimate that last estimated digit. Okay. That last estimated digit, I could see where it could be a 9, or you could think it was right over that line itself. If it was right over, if it was exactly on that line, it would be 7.9, and then I'd put a 0 in here to show that I was not at all uncertain about that 9. There is no uncertainty in this 9. But there is uncertainty right here, okay? In the same way that there's uncertainty here. I'm not 100% positive that that's a 9, that it's 0.89. It could be 0.90. It could be 0.91, okay? There's some uncertainty there. And these units are all in centimeters, okay? And so that's another example of how to measure length with the most accuracy and precision possible. All right, what is the length here in centimeters? And again, I went to sleep. Sorry, my computer bugged out on me there for a second. Alright, and let's click here and go screen, erase the pen. Okay, this one, the tack is lined up right at 0. Okay, and why don't you pause this for a moment and see, and I'll draw the line. Okay, and we'll draw that line right there. You tell me where this is falling. How many centimeters is it? Pause. Okay, welcome back. All right, so you were testing this out, trying to do your own thing. All right, well, it's definitely past the 2 and not yet to the 3. So I have a 2 there. and I want my units to be centimeters, so I'm going with the big bar stuff there. So then my decimal point goes in next. It's 1, 2, 3, 4, 5, 6 little lines over, and I'm very certain about that 6. I think it went straight on the line, and because I have no uncertainty, I'm going to add a 0. And that unit is centimeters. Now, what if instead of asking for the length in centimeters, what if it asked for the length in millimeters? Okay. Well, I know that there are 10 here, there are 20 here, and there are 6 there. So it would be 26 millimeters. Okay. Okay, and it looks like we were pretty close. Oops. Back, and I don't want to go all the way back through everything. I apologize. Let's get to that last slide. There it is. This one here. I like this a lot. This is also in your textbook, so pause, hold on to it, look at it. You are getting all the metric, the SI metric units. When you want to think of your width of your pinky is approximately the width of a centimeter, and they did this for volume, how 10 drops of water is usually about approximately equal to a milliliter. When we're talking mass, pardon me, okay, a large paper clip is about 1 gram. Okay, so it's helpful because I'll be asking the questions for you to think of common everyday objects that can help you remember the size of different metric units. Okay, for temperature, think about 21 degrees Celsius is room temperature. Okay, and then there's also this Kelvin scale. We'll talk a little more about the Kelvin scale. Don't expect you to know it right now. Okay, numeric values, the prefixes. You should know metric prefixes. Okay, when it comes to a metric prefix, there are kilo represents 1,000. Okay, deci is a tenth because there are 10 decimeters that make up 1 meter. Centimeter is a hundredth because there are 100 centimeters in every meter. And millimeter is in the 1,000th because there takes 1,000 little teeny tiny millimeters to make 1 meter. And then we've got micrometer and nanometer, and that's when things start getting real small. Okay, this is a billionth, and this is 100,000th, okay, of a meter. All right, and I hit the button again, and I think we're going to call it quits. All right, you guys have a great night, and I will see you shortly for section 1.2, time and distance.